Next, we're going to talk about OpenStack networking, Project Neutron. Neutron is very interesting because it used to be called Quantum. It was actually introduced in the Fulsome release and nicknamed Quantum. It was a standalone core project. It was built because we wanted to create a completely separated software-defined networking stack for the OpenStack ecosystem. SDN platforms are very common, and the advantage to SDN is they have to be open and be able to be written to, above, and below. It was actually renamed to Neutron at the Havana release, and this was due to a trademark conflict with the name Quantum. You're probably asking, why move on from Nova Networking? If it achieved all of the features that we talked about earlier, it seems like it would probably work for most people. Well, that was the challenge. There are still layer 2 boundary limitations that you were struck by. We have scalability limitations in the ability to deploy more than 4,094 VLANs. The reason why 4,094 is a number is because it's the 802.1q standard that only allows for VLAN names to be from 1 to 4,094. It seems like a very large limitation, really, and most people probably wouldn't bump into this. However, there are a lot of larger provider networks that are going to be running into this issue, and in fact, even traditional enterprise networks can be large enough where we could have conflicts around VLANs. There's also interoperability limitations, and this was because Nova Networking was very fulsome within OpenStack, but it didn't necessarily do well outside. Then along came Neutron. Neutron was built to be a completely separated environment. You now have Neutron nodes. So there will be a Neutron networking node deployed within our modular framework. As you can see on the far left-hand side, there's 3 agents that run. There's called the plugin agent, and that's the specific plugin based on the provider hardware or software even. A layer 3 agent, and then a DHCP agent in order to deploy IP DHCP services into that area. The compute node has a Neutron plugin agent running on it also, so that it can communicate with the network node. And then the controller node, as you can see about 3/4 of the way down the stack there, is a Neutron server. Again, a standalone component within the environment that allows it to communicate with the external network nodes. We now have a lot more granularity of control and scalability. Effectively, this is a full SDN platform. The addition of stretched VLANs and overlay networking completely eviscerated the boundaries that we were struck by with the layer 2 limitations. And effectively, a lot of other layer 2 and layer 3 limitations have been lifted thanks to the Nova networking model. How do we do that? Well, this is where we lean on the third-party vendors. Third-party vendors have a lot of great capabilities at the hardware and at software layers. So OpenStack was built using a modular layer 2 plugin framework, or ML2 for short. This creates a maximum flexibility and interoperability into the platform so that it made it easier for vendors to be able to interact with OpenStack. Rather than writing their drivers and having to commit code back into the actual core product, they can now write modular layer 2 plugins that interact with their physical and logical software networking layers. Much more flexibility and much more control. And we're seeing lots and lots of commitment from vendors already on being able to push in great, fulsome ML2 drivers. We support the same traditional topologies we had before, which were the local, flat, and VLAN networking models. But now we've introduced overlay technologies using encapsulation frameworks like GRE and VXLAN. Now, thanks to the ML2, we are able to tap into the physical networking builds with ease. Well, maybe not ease, but it's easier. Effectively, we've been able to now tap into all of the enhanced capabilities that are down in the physical layer, and we don't have to deal with as much difficulty in dealing with the intermediary drivers. It's good from the administration side, it's good from the developer side, and it's good from the vendor side. Effectively, we've created a much more flexible framework, and we're seeing great buy-in from all around.